Hi, and welcome to today's virtual JBug. For this session, we've got Tom Jenkinson from the Narayana Transaction Manager project to talk to you today, and I'll hand over to Tom. Hi, Tom. Thank you for coming.
Hi, Paul. Thank you very much for inviting me.
I'm just switching the equipment over. Right. So, if you could want to introduce yourself, Tom?
I will do. Is that actually on, thinking about now, or is it broadcasting this?
No, I can see you.
Okay.
I can see you on my computer.
Great. Yeah, so I'm Tom Jenkinson. I'm the lead of the Narayana project, which is a transaction manager. I work for Red Hat, but the source is all obviously open source. I've worked for Red Hat since 2008. I used to lead the black tie team, and as I say, lead the Narayana team. Black tie, as I'll come on to, is part of the transactions family. Yeah, that's about it, really. So without further ado, I'll move on. Apart from the fact that I need to now talk to Paul to make sure I know what's being broadcast.
You need to turn the screen
sharing on now.
You think you've not been to one of these before, Tom?
I know that there's usually a lot of messing around. I remember this, but it's on, yeah?
Yep, that's good.
Excellent. Okay, so today's talk is about Narayana, version 5 in particular, some of the new stuff that we've got. So what I'm going to be talking about is, I'm just going to lead off with why you might want a transaction manager, just to sort of set the scene for the rest of the discussion. Then I'm going to look at how you can embed Narayana in a few, if not unusual, not the traditional JEE environment, other environments. And then I'm going to finish off with just introducing a few of the new stuff that, alongside the containers that we've been working on, some of the new sort of language features that we're providing in Narayana. So, why you need a transaction manager? Basically, although it's a slightly contrived scenario, the general gist of it is that you basically don't want this situation to happen where you have a failure doing some critical work that takes in 2 or more operations that generally would be considered a unit that needs the sort of all or nothing property. And so that sort of motivates why we look at transactions. Basically to make these 2 in reality distinct operations become one single unit of work. When we think about a transaction, so this is sort of transactions 101 now, this is the baseline basically. When we think about transactions, we tend to describe a transaction with the so-called ACID properties. And when we think about transaction models, we think about whether that particular model, which I'll come on to, adheres or relaxes any of these properties. So the 4 properties are, now I'm going to guess that people in the audience may have heard of ACID properties before, but just for a recap, these 4 properties, basically atomicity relates to the sort of property of a transaction where everything's done or nothing's done. Consistency relates to the fact that the state of a system moves from one consistent state to a second. So even amongst those multiple resources, the state of the system conceptually moves from one to another. So that's consistency. Isolation basically means that the movement of the two states is shielded from other actors within that application. And then the durability property, it means that the changes from the transaction commitment basically survive any kind of failure. So as I say, that's an ACID transaction. An ACID transaction would adhere to all four of those properties. What we've seen a lot of research in is how those properties, although desirable in some situations, or a lot of situations, I should say, maybe with time, people consider how they can evolve new protocols which will relax some of these properties and maybe give other benefits, and the benefits typically revolve around overall system performance and throughput. So by relaxing some of those properties, you can generally achieve a balance of performance versus, well, one of those four. So for example, another protocol that's been around for a long time is the concept of a saga. And these are long-running transactions that will sacrifice, say, isolation. So some of the changes to do with the transaction are visible to outside the scope of that transaction. But by doing that relaxing of the isolation, it allows overall system throughput to be more, but as I say, you're at the risk then, or you've introduced the relaxation of the isolation, and so those changes are visible midway through a transaction. Now, Narayana implements these standard specifications. So the one that most people will be familiar with, I would imagine if you're from a JEE environment, is JTA. So when you're looking at, say, an application server and you're thinking, I've got a transaction, it's JTA, then in the Wildfly application server, that's provided by our project. We also provide an implementation of the OTS, which gives, it's basically like the Corba distribution of transaction contexts. JTA and JTS play together quite well. So you can have in an EJB, say, demarcated with JTA API, you can have that propagate over the JTS in the Java terms, have that transactional context propagate to another JVM or C application as its OTS compatible too, and so have the transaction span multiple machines. The other distribution technologies that we support, although they don't have to be accessed through JTA now, are WSAT and WSBA, that's for SOAP protocol sort of environments. The WSAT is an ACID transaction, so it had all the four of those properties that we talked about before, so atomicity, consistency, isolation, durability. You get that with WSAT. Or WSBA, which is a Saga's implementation, so where you're relaxing some of the isolation, but it typically works quite well in situations where, as we'll come on to, you can imagine compensation type behavior. And I'm going to discuss compensations a bit later on, as it's one of the areas that we've done quite a lot of work on recently. Narayana also supports C programs. The specification of transaction demarcation in that is, it's an X-Open one and it's called TM. It's very much like JTA, so begin, commit, transaction, but again, just from C or COBOL, although we don't do the COBOL bindings, but the TM API has COBOL bindings. And then I put it in the specification section because it is REST stars and org, but as far as I'm aware, we're the only implementation of REST AT. So we also have an ACID transaction API that applies to REST services. If you look at the REST sort of philosophy, if you will, transactions can be considered an antipattern possibly, but there are scenarios where you still need that behavior, and so you know, we've done a lot of work in that sphere. So we do have an AT implementation. We also have, there is a specification in merging, which is a Sagas like, well, it's not based on Sagas for REST, but the specification isn't at a state where we've implemented it yet. So as I say, Narayana implements all of those specifications, and in an environment where you're using it, you'll find it relating to XA and ATMI as well. So to put that a little bit in perspective of how it sort of works in a day-to-day area, at the top there, we've got our application programs, which is stuff that you guys would code. You would also have this sort of general area of resource manager. These are the type of things like databases or message brokers that you want to create a single atomic activity out of. So send a message and update a database. So those are your resource managers. And then on the bottom right there, we've got the sort of Narayana family of systems that interplay together to provide the actual transaction behavior. So I think I've just got a little link to show what some of those APIs in real terms of what you would be using. So as you can see, your application, so REST microservice, let's say, or an EJB, would be using, in the EJB sense probably, JDBC and JMS to interact with the resource managers. Your client would be talking JTA to the transaction manager, or REST-AT, WSAT, whatever, it doesn't matter, WSBA. And the interplay between the resource manager and the transaction manager in a JE environment will typically be XA, but again, it could be any of these specifications that that can be done over. So how the transaction manager can fulfill these contracts around ACID or the relaxation of those, one of the sort of main areas that you will come across if you attend a transactions lecture at university, let's say, is a two-phase commit protocol. So what I've done is I've taken a Java example and just sort of run through a few of the sequences of events that goes on with the two-phase commit protocol. So the nature of it being, you would generally start with having these two resources. And as I say, in the Java example, it makes sense to make them XA resources. You'd have these two resources and you would have a transaction manager somewhere. How those are actually obtained, references to those, you know, you can use your imagination. They come off an XA connection in JDBC or JMS, and the transaction manager is looked up from JNDI. It's not the point I'm trying to make, really. But you have access to these things, and they're readily accessible. So what you typically do then is the client is responsible for enlisting these XA resources with the transaction manager. Now, this is an example in Java, but that would be the same in any of the other specifications I've discussed. The client or someone operating as an agent for the client, like a JCA container, needs to tell the transaction manager about these resources. And the transaction manager then would enlist them within the transaction, and in XA at least it invokes an API marked in red so that the resource knows to associate any further activities such as this one with that transaction. So I put it in quotes that it's an XAR. At that point you probably will be operating on something like the connection that the XA resource was obtained from. But these operations here then are participating within the transaction. Then the client would be responsible for removing the resources from the transaction, and the transaction manager does some corresponding operations on it so that it knows that that part of the work is all complete. And then it can run through the two-phase commit protocol, which I've marked at the bottom, The client initiates it by telling it to commit or abort, which wouldn't be 2PC then, but in the commit. What the Narayana would then do is just execute a prepare on each of the resources. Depending on the outcome of that, it then just goes through and commits them. And then that's kind of, at a high level, what goes on. So it doesn't look that complicated, but a lot of the complexity of the transaction manager itself is really around when you make certain parts of this durable and how you guarantee that those asset properties are going to be respected in the case of failure. Because if there was no failure, you wouldn't need this 2PC protocol. But let's say you were so inclined to write one, if there was no failure, it would not be hard to do this. So it's the complexity is in ensuring that these events are recorded and able to be replayed in the event of a failure. I'm just going to round out this end of this section with indicating a few of the APIs that aren't standardized that we have gone ahead and provided in Narayana. So if you go to, say, I'll stick with Java, if you go to someone like IBM or Oracle, you won't get these. These are things that we've created. Well, I'd say you will get derivatives of these, but they will be different APIs and different people's take on it. But these are the ones that we provide. I've called it TX Core. Sometimes people refer to it as Arjuna Core. It's kind of where our project started. It's the heart of the transaction manager, and you can code directly against it. So even in a Java environment, you might choose to interact directly with Arjuna Core to do some, interesting stuff outside the scope of JTA. We then have TXOJ, which is basically a concurrency control mechanism, which is quite important for transaction managers. Then I'll be talking about it, as I say, a little later. Our compensations framework that we've developed as a team, and then software transactional memory is a new API that we're developing at the moment. And again, I've got some examples about that shortly. And then we also provide a few utilities. If you're familiar with JCA, we've got a very light version of that in terms of transactional driver, but it definitely has its use cases. And then we also have some tooling for query stuff, so as you might expect. Just a few final terms. In terms of transactions, you tend to refer to them as either global, distributed, or local. Local transactions apply to a single resource manager and don't really have any interaction with Narayana. Global transactions include more than one resource manager, and then distributed include more than one, say, node. And then when we look at recovery, which is a key part of providing any kind of transaction manager guarantees around asset properties, you have a concept of bottom-up recovery, which is where node resource managers come back online and dial home to the transaction manager to find out what happened, and then top-down, where the transaction manager locates those and recovers them. We might touch on it because all of the implementations, so REST-AT, WSAT, JTA, JTS, need those kind of capabilities, and we have implementations of those, so it may come across in the example. So that's the first section. We're on to the second section now, and this is how we use Narayana in a few containers. And this is where the demos will shortly start, so fingers crossed. The first one I'm not going to go into too much. As I mentioned at the start, we are the JTA implementation in Wildfly. We also provide other services inside the Wildfly container. We have our REST-AT and a WSAT coordinators. We've got our WSBA Sagas coordinator service. Those are out of the box. You can configure those with Wildfly that you download. You can enable those quite easily. We've also provided an XATMI integration, which is black tie, which can be added on top of Wildfly. It doesn't come out of the box. So, you can go, there's lots of resources, quick starts and whatnot for how to work with Wildfly. And you know, it's a massive consumer of Narayana. I wouldn't be able to give you metrics, but I imagine most of our users are via Wildfly. So, you know, there are a lot of resources there. So what I am going to show you is how to start up a standalone transaction manager in a Docker container. And I just tried it before, and the new IP address that I'm on here didn't work initially, but I think I've got it working now. So it should be exciting. So let's go there. So the first thing I'm going to show you is how to launch. I'm not actually going to do this. I'm just showing it for completeness. Our XTS container, and this one's RTS, but they're pretty similar, can be launched in Docker with very, very simple Docker file. Because it's built on top of Wildfly, and it utilizes all the services that already exist there. So all we're really doing, for those familiar with Wildfly, is replacing the configuration to enable it. And that'll just boot up in this case, a REST AT coordinator using Wildfly. So I'm not going to go into that one too much because it's a bit too simple, and I know that one would work. So remove the fun from it. So what I am going to do is go onto the running a standalone JTS server using Docker. Gitters has been doing this work, and it's not finalized yet, and we definitely need feedback on this, and that's one of the things with these demos that I'm going to do now. You know, hopefully people will be interested and may be able to suggest new ways of looking at what we're doing. So as I said, Gitters has been looking into it, and this is what we've got at the moment. So let's see how it goes. Now I'm on Windows, so see how that goes. Right. On Windows, for those not in the know, use something called boot to Docker. That one's up. And into the virtual machine. So we're now in a Docker environment. So, as you may have just spotted on the slide, Gitters is doing this work on GitHub, so it's really easy to sort of on it, but it's in the it's in one of his repos anyway. I've had to modify it for today because it didn't quite work exactly out of the box, so I'll be putting those changes back shortly. So I think it was mainly a nuance of Windows, really. Right, so I'm going to close that one because that's not the one we're looking at. So the first thing I'm going to do is start a Corba naming service. With it being the JTS, one of the techniques that we found that's going to be easiest to expose the connection details for the transaction manager is via the Corba naming service. So the Docker file for it, this is the name service. As you can see, it just downloads Jacob's name service and fires it up. So there's nothing too exciting there. What's useful for me is the instructions are there. So just go into the name server folder, hide that, and paste that. I've already built it, so it was very quick. I'm going to run it up. That's our Corba name service. Now, again, in different Docker container, I'm now going to fire up the transaction service. We're quite new to Docker, so apparently it's best practice to have them running in their own containers from what we've read. So this is a Docker file for the transaction manager. As you can see, it downloads a transaction manager, modifies a few configuration options, which are described if you're so motivated to look at the information online, and then fires up the transaction manager with the recovery manager embedded in it. Okay, I think it's already built, yeah, so that's just going to launch straight away. Well, build straight away. Now going to deploy it. I think I'll be okay because I prefer kneeling. Keeps me on my toes, but not literally, obviously. So that's our transaction manager fired up. So again, in a Docker container, it was quite easy to do. And then from my host, I'm now going to hopefully run a quick test, which is going to connect to that host and do a simple JTS transaction on it, where I'm going to connect to the transaction manager via the Corba name service, and then create a transaction, register 2 resources, and commit it. As you can see below, I don't know if this shows a lack of confidence on my part, but as you can see below, I have done it before, and we expect to see something similar, but try to imprint that on your mind in case it doesn't happen. We're going to see the transaction be created. We're going to see these resources prepare. They're going to vert to commit, and it's going to commit. Fingers crossed. Yeah, there we go. So it was quite easy to do, but it just shows one of the areas that we think might be interesting. Docker seems to be gaining traction. So we can easily host REST AT coordinators or WSAT coordinators. Potentially in a Docker environment with microservices, we might see a more interest in the RTS coordinator. It's difficult to say at the moment, but you know, it's a similar technique anyway. So yeah, it's definitely feasible with our project. I don't think there's too much else to say on Docker really. It's something that sort of, you know, we're just participating in part of the community really. So we work with it. Yeah, if you've got any suggestions offline, let us know. So the next container that I'm going to be looking at is how to kick off a REST AT coordinator in Undertow. Undertow is the web server for Wildfly, so unsurprisingly, we deploy into it. However, and it's maybe a tech demo of Undertow as much as anything, it just shows how simple it is to deploy the REST AT framework, this coordinator and its recovery manager and etc. in an Undertow server in just a few lines. So if I just flick back to the IDE, I'll just show you that code and then I'll just kick it off in here. So what you can see is what this example does is that basically fires up a Undertow server with REST AT deployed. Now, because the test is a little bit more comprehensive than just firing up the coordinator, the next sort of 2 sections also fires up 2 separate servers in the same JVM, but they could just as easily be in multiple JVMs because they're on different ports. It's just multiple servers. So we're going to find a situation now where we have one REST AT coordinator server, and we're going to have 2 dummy participants, and then I'm going to interact with those over a simple curl and wget type situation, just to create a transaction, interact with those 2 services, and then commit the transaction. Now this code, as I say, is all in, well, I didn't really say, but Mike developed this code, and it's all in our quick starts repository, so you can easily try this at home, so to speak. So the first thing to do is just fire up those servers, and I'm pretty confident they'll fire up. Yeah, there we go. So these print lines are in here somewhere. I think it must be when the server starts. I'm not going into too many details because they are there. But it's just something that we've coded into the thing. So we've now got the REST STM, quick start, RTS, AT, editor. So as I say, I'm now just going to interact with those running servers. Where's the thing disappeared? Is that one? Yeah. So a little script in the quick start folder, just the utilities. Just quickly show it. As you can see, it's just curls and gets, posts, etc. So it's all pretty simple stuff you can do from shell. So I'm going to start a transaction. When you start a transaction with REST AT, you get back a link to three things. You get a link to the terminator, which is how you actually complete the transactions, and you get a link to where you should enlist your participants. If you remember back to that 2PC thing, with JTA, it's quite easy because it's all in the same VM, so you could just call enlist on the actual object that you get back. With these distributed technologies, you have to come up with new ways to do that, and so we return link headers to where to actually enlist your participant. That's the second one. And then you also have the flexibility to add what we call in REST AT volatile participants, but if you're familiar with JTA, they're more like synchronizations. And those are the three things you get back when you create a transaction. So what we're going to do now is we're going to enlist with that transaction. So that transaction is going to be dead, so I'm going to create another one because I only created it with 10 seconds. Millis, that's 100. Should be all right with 1,000, hopefully. Created, right. I'm going to access that. If you remember, there were three things I started up. I'm now going to access I've already accessed the coordinator. I'm now going to access the first dummy service, and I'm going to enlist them with the transaction manager. And I've got HTTP 200 OK. It's RESTful, so you'd expect something like that. I'm going to talk to the other service, as you might be seeing, is on a different port to the first one. Again, he needs the link to the where to register. Come on to that in the code. The way that that's defined is the way that a service obtains a reference to the coordinator is not part of the spec, and it's left up to implementations to do that. You could pass it in a file, or we've passed it in an unRESTful way as a query parameter. You can pass it in the body, whatever. Final thing to do is complete that transaction. That got the 200 OK. So now if we do tx control, tx control minus list, we'll see there shouldn't be any transactions on unless, yeah, there we go. So 2PC transaction happened. I think we'll probably see in the console some information. We got the first one timing out that I created that only lasted a second, and then the transaction committing on the service. So what I wanted to show you was the requirements of a resource that participates in a REST AT transaction. Generally speaking, these are all in the spec, but what was interesting about that particular, this is the business logic. Some service request is the business logic. And as you can see, the enlist URL was passed as a query parameter. As I was saying, the way that that's passed in isn't defined in the spec. So it was just a manifestation that we've done here. And I think that's pretty much most of what I needed to say. I wanted to show how it's enlisted. So remember, this is in the participant. He's been given the URL of the transaction in some method. And so the way he tells the transaction manager he exists, because the transaction manager is so far unaware, is he invokes on that enlist URL, does a post with some headers, and those headers contain, this is the key one, it contains a link back to this participant so that the transaction manager can then invoke the prepare and commit on him. So that shows REST AT started in under toe.
So is there an API that each resource needs to implement in order for the coordinator to...
Exactly. Yeah, exactly. The question was whether there was an API that the resource needs to implement, and I responded exactly. But to qualify that, it's not a Java API, obviously. It's a REST. Yeah, it's. But there's basically some URLs that you need to send back, and it's going to, and the coordinator is going to put some posts and heads on those to basically that you need to be able to respond to.
Is the coordinator of a client API as well to start the transaction?
So the way that the transaction was started was, I've still got it open. Where has he gone? It's up there somewhere. So if you remember, I use -s, start PX. So the start PX can be done like this, or obviously programmatically in a application. I'll just remove that. So it's so you do a post to the transaction factory, and that creates you a transaction, and it returns in the body. Is it the body, Mike? The links to the coordinator. It returns link headers, so it returns headers back with the terminator, the link to register participants, and the link to register synchronizations in quotes. So that's, it's an API, if you will, a REST API that you do a post to that, and the convention is you get back some link. The coordinator will have created a transaction, and it returns you the links that you need to enlist or complete.
And can you just have the REST head on the transaction coordinator?
Can you do what, sorry?
Just have the client side REST head, and then everything else, and then have a standard XA.
It's not XA. It's we do support bridging. So what that means is we can have an EJB participate in a transaction that was created as a REST AT transaction. So once it hits that app server, your application can then invoke EJBs, and that transaction will propagate through as a JTA transaction. Can come back out over, again, over bridging. It could come out over WSAT and come back in, and so on and so forth. So we bridge between all of these APIs. So you could have something start as a JTA transaction and bridge out over SAT, and etc. So it's I don't know if we're the only people that do that, but it's definitely one of the areas that we're looking, strong on, is that sort of flexibility. It's also conceivable that you can, interact with, say, a Saga like a transaction as well, and sort of get a mix and match and all sorts. So I think that might be my next JBug, when I try to throw it all in to one example. Yeah, so again, while I've got this open, you can see that the commit is done by doing a put onto this $1 would be the terminator URL that you got back on the create. So that's how you can tell it to commit or abort, etc. You know, it's on REST Star. You can download the spec and take a look, or just kick the tires with REST AT. Yeah, that's that bit. The next thing I'm going to show is how to fire up, how to get JCA transactions into Tomcat. I've not got that much time left, so I've got a few other topics. There's two ways that we do it. We do a tight integration using the Tomcat sort of techniques that are used to enlist things in their naming and whatnot, or we have this sort of more flexible approach that would work on any servlet container, to be honest, which is to use IronJackamar in its embedded mode as a servlet container, because that fires off, that can fire up transaction managers. And as you'll see when I just show you through the code, it gives you a much more sort of, if you're into JEE, it'll give you a more familiar environment. You know, your data sources are bound, and etc. So if you're interested in the more Tomcat-oriented approach, that information's on our website, so you can find that easily. So in terms of actually showing you this, I think I'll start with the code. So it's in our quick start repository, so it's something that you can go and play with. This is the sort of structure of it. Let's take a look in the POM at what we're actually going to be doing. I'm not going to be firing it up in that, so minimize that. Look at the dependencies, so that's the sort of. So this example uses JSF for the rendering of the pages. It's obviously got servlet. These are all for IronJackamar. It's clearly marked in the POM. Don't know where IronJackamar stopped and transaction started, but it still looks like. Anyway, there's quite a few dependencies, but generally we're going to get an IronJackamar container, and it's going to be able to give us transactions, and it's going to be able to give us data sources. I'm not going to the controller. This is the key bit, really, the servlet context listener. It's quite a small class, and all it does is fire up this embedded IronJackamar. But what that gives us then is a flexibility to write code that uses connections from IronJackamar, so you can look at data sources and those can participate in a transaction. So to make it a two-phase commit, what I've got is we've just got a dummy XA resource, and we're going to use H2, which is a lightweight database. So let's see how this goes. CD. Already cleaned out Apache, so I'm just going to unzip the latest one that I could find on the web. Just going to rebuild the example. So that's just building the source code that I was just showing. I'm going to copy it into the Tomcat folder. I fire up Tomcat, and it's in use, but that's okay. It's probably boot to Docker that needs shutting down. There we go. It's up. Browser. Where is hiding? So this is, it could just as easily be deployed on Wildfly, something like this. So I'll type in Wildfly, even though we're in Tomcat. Now, What have we done here? Okay, it's using Postgres, which means I've probably updated it. Out of the box, the example was set up to use Postgres, and it looks like during my prep, I have changed it to use H2. I'm just going to confirm that, and if I have, I'm not going to waste everyone's time by, yeah. Probably come back to that if we've got time later, if we have time. But generally, it was an application that just updated the database and incremented a counter. So the final area that I'm going to talk to you today about are these 3 new features that were added in Narayana 5. So the compensations framework is it's a Saga's type approach, so it's not ACID transactions. It's the ability to selectively, well, not in the current implementation, you can't actually do consensus groups, but Saga's allows you to do that. I'll come on to that shortly. But basically, rather than having like all the properties of ACID transaction, sorry, chasing the microphone. It allows you to, say, do a piece of work, and it means that you don't have to hold the locks, basically. So what I should have mentioned when I was talking about those ACID properties is one of the ways that ACID transactions tend to be implemented is via locking. And so that has the consequence that it can impact performance when you've got competing transactions that are locking resources. Poorly written applications can deadlock, but even well-written applications, they can starve each other because they need to lock resources, and potentially in the presence of failure, those resources can remain for a long time. So what the compensations framework in Saga's tends to do is it tends to relax isolation, and that means that you don't have to hold the locks. There's more to it than that, but at a very high level, you can see it as relaxing isolation. It also has another impact on the ACID properties in the sense of it's eventually consistent. So it doesn't mutate straight from state 1 to state 2. Those changes are visible. So it will guarantee that you'll get to state 2, but due to lack of isolation, there's not a sort of guarantee that that's going to be in lockstep. Narayana's had Saga implementation for a long time, so WSBA is, old to us. The compensations framework is new to us in the sense that it's an API that our previous Saga's implementation was around distribution, so WSBA, so the compensations framework has a local implementation, so you can develop your code much like with our JTA bridging that I was talking about, moving between REST-AT, WSAT, JTS, moving it around to different nodes all the time. Our compensations framework is designed to allow us to do these sort of activities either in one VM or bridge them to other domains using the transports we have. For those familiar with JTA 1.2, it's got a set of annotations that are similar to that. So rather than at transactional, we've got apt compensatable. And then there are 2 sort of annotations that you have to be aware of, really, which is the compensate and the confirm. So those indicate which of your business logic to execute if the transaction either is intended to complete or is intended to sort of abort, if you will. Those are bindings in Java. So it is fair to say that this is going to be a Java API, although the techniques are applicable to any language. Currently, it's a Java API. Now, we've got another example, so see how that goes. Pretty sure I only had 1 slide on that. So Paul did an very own Paul Robinson, Maestro, did an excellent series of blogs on that, which I've chopped the URL on because I don't like him having any glory. But can circulate that to interested parties later. But he has a series of blogs that describe this, and I'm just going to show you the code and give you a little sort of put it in context. Although Paul did an admirable job with it.
If you Google for Narayana compensating transactions,
you probably get them. Yeah.
The blog series is the first hit.
I'm
going to repeat that because I don't think it's also the microphone to be pointed as well.
Yeah. What was it? Sorry. If you Google Narayana compensations, then you'll not find it, Paul says. So good luck. I've given you part of the URL, and you just have to guess the rest. Okay, so the example itself, again, as you might expect, it's in our quick starts repository. So let's maybe start with the test, as it's small. I'm not going to go into it too much. Basically, you can see that it's an Archillian test. So one of the things that is a current requirement of our compensations framework is that it is deployed inside Wildfly. Now, that isn't to leverage the XTS environment or the RTS, it's to leverage its CDI environment. So it's not a hard requirement that it be deployed in Wildfly, it's just a current requirement, an implementation restriction at the moment. It should deploy into something like a Weld container quite easily. Paul's done some work to do that, so or to validate that.
So yeah, I've got a proof of concept where compensation framework runs in Weld, which is a CDI framework that you can run outside the application server. Mm-hmm. So it's technically possible, just needs tidying up. Yeah. So if you didn't hear that, would they have heard that? Possibly.
Paul was saying that he's got a prototype in Weld. He's got a prototype branch. The point that I want to make though is that even if it's not a requirement that it deploys into Wildfly, if you are wanting to move outside of the JVM and propagate to other nodes, you know, it has advantages that it's in Wildfly or another container, such that you can sort of use the WSAT, REST-AT to maybe propagate the REST Saga's implementation that we don't have at the moment, but in theory, you know, it would be advantageous to be in some kind of other container. So the CDI environment is just injected in this book service, and probably just before I go there, the last thing I want to show you on the test is that the test just calls my book. So as you can see, book service, the main thing is to mark that this is compensatable. So this is like saying it requires a transaction. But in this case, it's saying it requires a compensatable transaction. Now, that piece of business logic itself obviously isn't transactional, it's just where the actual transaction boundary is. And the two things that are being done in that transactional boundary is to dispatch a package, in this case, containing a book to a person, and it's printing out an invoice. Those two things were chosen because they're not things that are inherently things that you can actually roll back in like a classical sort of ACID situation. You can't just roll them back. They've happened. You've sent that parcel. You've printed that invoice. So they don't lend themselves to an ACID, sort of an XA style transaction, but they do lend themselves, as we'll see, to a compensatable transaction. So if you look at the dispatch, this has a couple of things to point out. There's something called order data that was injected, and all I want to say there is that it's marked as compensation scoped. If you're familiar with JTA 1.2, it's a bit like transaction scoped. It's an item of data that pertains specifically to this particular transaction. The other thing I wanted to point out about this package dispatcher is it has marked up what method to call when you need to compensate, which is sort of like abort, but not obviously, because it's not the same, but it's kind of like if you need to sort of try to undo the work you've done. So and it's marked up with the recall package. So as you can see, it's not always amazing what you can do with your compensation, because it is something that has actually occurred. So in this example, Paul has printed out a message, we need to recall the package. But the benefit of it is that you know that needs, you can put what you want in here and that is going to happen, that thing there, and that you can guarantee that print line will be called. Or in the case of the invoice being printed, we have a compensate on this, and we have a destroy invoice function, and again you can guarantee that someone will be told to hunt down that invoice. So although this is quite a simple example, it shows some of the sort of techniques, and you can imagine using these to do something potentially more sophisticated. So with an airline, for instance, that's booking seats, it allows you to, for example, overbook seats and define some business logic what to do if all the passengers turn up, such as bump them to first class, offer compensation, those kind of things. So it just basically gives you a way to think about the problem and to define activities to do when the transaction isn't able to be completed. So yeah, that's the sort of compensations framework. I'm not going to run this demo because basically it's a test and it just works, so there's no real point in. But hopefully it's just giving you some idea of what you can think about doing with our framework. And we're always wanting feedback, because this is evolving. So we definitely would appreciate people looking at it and telling us what they think's missing and whatnot. One of our own implementations, if you will, of this compensations framework is we have in the team had a patent submitted for it actually, and it basically uses compensations-like approach to allow you to include non-transaction aware resources, so non-atomic transaction aware resources, so things where you can't update multiple entities within that resource manager within the scope of a transaction. We've applied that technique to MongoDB, and so we have a driver in development that allows you to update multiple tables using our compensations framework under the hood. And so therefore, rather than having no ASCII properties when you update multiple tables, you can get atomicity, durability, eventual consistency, still with relaxation on isolation. The sort of secret sauce, if you will, is to embed some transactional data in with your updates to your tables that you can either compensate, i.e. basically try to remove the data that you had, or you can confirm, which basically just strips out the transactional data. So that is in development, so I can't demo that today, but that's one of the things we're looking at the moment. And then the final area to talk to you today about is software transactional memory. I don't know who's familiar with this, but Mark Little, who is our sort of like guide and mentor and whatnot through the transactions world, is leading development of this for ourselves. It's fair to point out that STM isn't a Red Hat thing, especially. It's there's other implementations of STM, but Mark's leading ours. So STM is basically, the problem is trying to address is when you've got lots of concurrency happening, but you want to update shared state, and you don't want to hold locks because you don't want to reduce, you don't want to throttle the performance of the system by holding the locks around those things. So what STM allows you to do is it allows you to have these sort of, it's implemented with two different techniques, but basically it allows you to not lock the data, and if it detects lock issues, so there is a concept of a lock there in our implementation, but it's not a held lock, it's just a checked lock. And generally with STM, there's two sort of techniques for checking these locks. You can do pessimistic check-in, which is the default that we use, but it doesn't have, it's not the only one that you can do, and that checks the locks as you're executing code. So you've got two threads going, one of them, say, updates the state, and the other thread comes along and tries to get the state. If it's pessimistic lock-in, it'll get an error at that point. Whereas optimistic concurrency control allows, let's say, if they were doing gets, well, the previous example would be the same with get, but so it doesn't have to be a write and a read. With optimistic, if they're both doing gets, then it can get to the end, and because it detects no conflict, both of those are allowed to commit OK. So that's the benefit of optimistic over pessimistic. If you read heavy, you're not going to get any lock failures, and also you've not had to lock anything. What we find with STM implementations is that generally they relax durability. By the nature of it, with it being transactional memory, you would tend to think that those objects are not necessarily durable. So if it's a counter or something, there's no necessarily any need to make that durable and a way to sort of reconnect to that object after recovery. But obviously our implementation does allow that. And it does that through basically configuration of our container. But it's a detail really, because you can turn it off or on, and most people will probably have it off, so to speak. So again, we're just developing some quick starts for that. These aren't in the actual repository at the moment, but there will be a pull request for them shortly. I'll start with optimistic. So again, there's annotations. It's Java for us. There are Haskell implementations of STM that we haven't done. There are all sorts of implementations. Somewhere it's native to the language, somewhere it's a third-party library. In our case, it's a third-party library. Java doesn't have native STM. So this is the interface to our object that's going to be an STM object. You can see it's got transactional, which it's coming out of the STM package. So whether we would rename that, I don't know, because transactional, there are other transactional, but you can obviously qualify it. And then it's an optimistic object that this particular example is using. The implementation of that object defines what locks are required. If they're not provided, the implementation will assume the right locks that you need. So in that way, that one isn't actually required really. So I got a read lock and a write lock. And the example itself shows optimistic concurrency control in action. So as you'll recall, the optimistic concurrency control doesn't check the lock until the commit point. So in this example here, we create the container, which, as I mentioned, it's kind of an implementation thing. Generally, you don't need to configure it. I think I've chosen the defaults there. Not only can you configure persistency here, you can also say whether you want the object to be shared in different JVMs, for example. So, that could just as easily be for this example, and it's all in our docs. So we create an instance of the implementation and pass it to the container and get back the interface that you can interact with it. So that's our object one. Again, it's the interface you've defined. And then the same for the second object. There is an issue at the moment with optimistic lock-in, so I'll not go into it too much. You can look it up. So we're going to create a transaction, begin it, set. So that's the write lock. Suspend it, create another one, another transaction, set on the other instance of the example STM, commit it, and when you resume try to commit it, you'll find it can't commit because the locks were checked during commit. Now, I could run it and you can see it pass, but I'll not bother because you can see it here. So the key thing is that the lock was checked during the commit. And then at the end, it verifies that the data was correct. As I say, that is it, this example, so it's not really worth running. So that's the optimistic concurrency control. I'll now contrast that with the pessimistic version.
Oh, is there a bug in that one? It says object right at the bottom when it's testing in object1.get or object1.get.
Oh, there is a bug, yeah, but that's right. Yeah, they both should be the same. I'll definitely not run it now or it might fail. So this is the same interface more or less. It's got the pessimistic annotation. It's optional because it's the default, but keep it in there. Same implementation of example STM. Pessimistic control is again, this pessimistic control isn't influenced by those, so those are optional. You create an instance and you clone it. You might look like I'm creating two different instances, which I obviously am, but there's the reference to the other one here, and that's just the way it's done. You don't actually you don't invoke methods on the STM, the implementation itself, otherwise it'd happen outside of the STM, so it's not really worth it. So yeah, it's these two references, but conceptually they point to the same object or the same software transactional memory, just different references to the object. Create a transaction, do the set, which gets the write lock, suspend it, and now you can see the difference with pessimistic control, where when you did the set then, on the second object, the lock will be checked at that time, and you'll get an exception at that point, and you know, your abort would happen there. So it really depends on whether or not you read heavy, write heavy, whether or not checking the locks early is going to be advantageous or not for your particular application. I've gone 10 minutes over, so I'm not going to go too much more. I had the Tomcat example, which didn't work actually anyway, coincidentally. I was going to edit that so that the dummy XA resource that counted the number of transactions that committed, I was going to change that to an STM object, just to show you that you can, with the Narayana implementation, you can have a JTA demarcation of a transaction and use software transactional memory within it. So you can update a database and have this counter, which is what the Tomcat example did. It doesn't have to be an XA resource now, it can be STM object. Now, I will just quickly show the code, as I think I've got it. Yeah, I've got a simpler, a more straightforward example that does the same thing. So an optimistic atomic object, example implementation, the same. So this time the STM, that bit there. So it basically creates a JTA transaction and lists a simple XA resource. So it gets a reference to the transaction manager, begins the transaction, and lists the resource, and then calls set on the software transactional memory. And basically, because it's an optimistic lock, and I acquired that lock up here, it basically prevents the JTA transaction from committing because the STM had a write lock violation. So we could have seen that in the Tomcat example too. But that was the main thing, to show that you don't have to use all of our APIs. You can just have a JTA transaction and mark it up as, mark your object as transactional memory, and it will participate just fine there. Again, it's in development, really need feedback. The final thing we're doing, which is really just in this slide, is we have looked at You might recall back from that diagram that had the application program at the top, the Narayana family, and the resource managers. There was the transaction login there. I haven't talked about it too much, but it's obviously a key part of what a transaction manager provides. It's the thing that contains the records of what's committed and what's not, etc. Some of the performance, a lot of the performance cost of the transaction manager is in the persistence of that data. So we are looking at new techniques that we can apply, and one of those is a data grid. But as I mentioned there, we had a really skilled student looking at this for us, and one of the issues we came up against was basically CAP. And for those not familiar with it, it's probably best read online, but basically the P is partition tolerance, and so what we found was that it's very difficult to cope with partition well, the sacrifice on availability, which is another part of the CAP theorem, it was difficult to guarantee that a majority of nodes were going to be up in the environment that we were hoping to aim this at. So you basically became, your partition tolerance was we couldn't guarantee that a majority of nodes were going to be up. We're going to deploy it on OpenShift, which basically grows and shrinks the nodes all the time and when they get offline. So as soon as you went below a majority, you couldn't actually do recovery because you couldn't guarantee, due to partition tolerance, that there wasn't two recovery managers running and they'd be operating on the same data, and then a lot of bad things happen. It's just a teaser. I would encourage you to talk to us on our forums if you've got any ideas about it. Last slide is just a link to where you can find more information. But apart from that, I'd just like to thank everyone for attending today. And sorry, my Tomcat example didn't work. I know I put it on the actual abstract, so I'm sure there's going to be millions of disappointed people out there in YouTube land. The end. Peace out.
I was just checking to see if there's any questions. Mute your microphone so it doesn't wobble. Come on. Okay, so it's muted. Okay, so I think we've. Is there any more questions? No. Okay, so I don't have any more questions in the chat room. So I think people were asking as they went through. So thank you very much, Tom.
No problem at all.
Very interesting.
Thank you for inviting me.
Oh, you're welcome.
I'll be back next year with my big example that throws it all in a big pot and then collapses in the first 5 minutes.
Excellent. We'll use that
Look
as.
forward to that one.
Yeah, we'll play this back to you next year.
Yeah.
Thank you, Tom, and thank you for watching. Hope you found it interesting. Bye bye.